Okay, what we're going to learn about today is we're going to learn about radicals and rewriting expressions involving radicals, okay, to prepare us for the next section. Now, some of you have worked with radicals this year in Algebra 2, some haven't, some worked with radicals in Algebra 1. Okay, I'm just going to give you a kind of a review with this lesson on simplifying radicals. All right, now there's certain parts to a radical. There is the radical itself. Okay, the radical sign itself. All right, and then there's usually sometimes a number here that's called the index. Okay, now if there's no number there, the index is automatically 2, which means square root of 9. Okay, sometimes we'll do cube root, or the index will be 3, and you'll see a 3 at that spot. Okay. The number itself, or whatever's inside the radical sign, is called the radicand. Okay, so those are the parts to a radical. How do we solve radicals? What are radicals? Radicals are the inverse of exponents. Because if we do the square root of 9, we all know that the square root of 9 is 3. Okay, because 3 squared equals 9. Okay? All right, and how do we treat radicals? Okay, we treat radicals similar to treating variables. Okay, so like the variable x. All right, if we're going to look at this equation here, we have 2x plus x equals what? Well, remember the invisible one in front of the x. 2x plus x equals 3x. Okay, similar to that, if we have a radical, let's say it's rad 3. Okay, if we have 2 rad 3 plus rad 3, well, that's 3 rad 3. Okay, so we're just adding the numbers out in front of the radical, similar to it being like x. All right, same thing here. If we did 2x times 3x, well, we have, let me do this instead. Sorry about that. 2 times 3x is 6x. Well, if we did 2 times 3 rad 3, okay, we would just multiply the 2 and the 3. All right, just like we multiplied the 2 and the 3 with 2 times 3x. So we have 6 rad 3 as our answer. All right. Finally, we get to here where we have 3x plus 2y. Well, there's nothing we could do here because they're not like terms. So the answer would be 3x plus 2y. All right, there's nothing we could do there. Same thing as if we had 3 rad 5 plus 2 rad 3. All right, we can't combine those. All right, so the answer is the same thing. Okay, I'm not going to rewrite it because it probably won't fit it. All right, lastly, we have 3x times 2y. We can multiply them. That's going to be 6xy. All right, same thing. All right, but a little different with a little twist here. If I have 3 rad 2 plus 2 rad 3, okay, then I have 6 rad 6. All right, 3 times 2, and then radical 2 times radical 3. I'm sorry. Radical 2 times radical 3 is radical 6. All right, so there's my answer for that one. All right, the change here is x times y. We don't really know what x and y is. All right, but we do know what 2 times 3 is, and that's 6. So it's a little change. All right. All right. On to the next slide. And we have our squares. Just to review our squares, because it's going to help us simplify these radicals. All right. We all should know all of these. Maybe not up until 15, but close to it. All right. We all know that 1 squared is 1. 2 squared is 4. 3 squared is 9, 4 squared is 16, 5 squared is 25, so forth, and so on. Okay, this is important for dealing with simplifying these because we know that the square root of 1 equals 1. The square root of 4 equals 2. The square root of 9 equals 3. 16 equals 4. Square root of 25 equals 5. Square root of 36 equals 6. Square root of 49 equals 7. Square root of 64 equals 8. Square root of 81 equals 9. Square root of 100 equals 10. Okay. I want you to write Panther on the right corner of this page. Okay. So go ahead and do that. All right, and then let's finish up with these. 121, because the square root of 121 equals 11. 144, square root of 144 equals 12. 169, square root of 169 equals 13. 196, I think that's right. The square root of 196 equals 14. 225. The square root of 225 equals 15. Okay, that's a lot. You probably won't be dealing with anything over 12, but if you get up to 15, that's great. Okay? All right, but you need to know these, what we call our perfect squares. Perfect squares. Because 9 is the perfect square, because 3 squared equals 9, and the square root of 9 is 3. So 9 is called the perfect square. All right, that's going to help us out with simplifying the radicals. All right, so we have, for an example, the square root of 32. Now, the square root of 32 is not a perfect square. Okay, it's not up here. All right, but we know it's somewhere around here. It's between the square root of 25 and square root of 36. So we can approximate what its value is. It's going to be about 5.6 or 7. It's a little closer to 36 than the square root of 25. All right, so it might be 5.7. Okay. Now we know that, but if I wanted to just write it in radical form, what I'm going to do is try to find a factor that's a perfect square that can factor into 32, such as, all right, which one of these perfect squares are factors of 32? All right, well, one is a factor of anything. 4, because 4 going to 32? Yes. Okay, 9 going to 32? No. 16? Yeah, 16 goes into 32. Okay, it's actually half of it. All right, 25, no. 36, no. All right, and we're past 32. Okay, so 16 can go into 32. How many times? 2 times. So 32 can be split up into factors of 16 and 2, where in this case it's the square root of 16 and the square root of 2. Okay? Because 16 times 2 is 32. All right. Now what happens here is square root of 16 is a perfect square, so we know that that's just 4. And the square root of 2 is not a perfect square, so that's just the square root of 2. All right. So now we're left with 4 and the square root of 2, so our answer is going to be 4 square root 2. That is this simplified in radical form. Let's look at another one. The square root of 128. Okay. Which perfect square does that goes into 128? Which perfect square is a factor of 128? Okay, well, if you don't know, instead of searching for one, what you can do is just say, all right, maybe 4. Let's see if 4 goes into it. So the square root of 4 goes into 128. Let's see how many times. 3, 2, 32. Okay, so square root of 4 times the square root of 32 equals 128, or you can find 32 out by doing 128 divided by 4. All right, now you could break this down. I know the square root of 4 is a perfect square, and that's just going to be 2. We just learned about the square root of 32, which was the square root of 16 and the square root of 2. All right, the square root of 16 is also a perfect square. That's 4. And the square root of 2 is in its simplest form. All right, so what we're going to do is we're going to take each end of these branches that we've made by factoring, okay, and we're going to multiply them together. So we have 2 times 4 times the square root of 2. Well, what's 2 times 4? That's 8. Square root of 2 is by itself. We can't combine that with 2 and 4, so we have 8 square root 2. All right, so this is simplified version of this. Okay? What this tells us is this 8 right here. What is 8 squared? 8 squared is square root of 8 squared is 64. We could have pulled out 64 from the 128 instead of the square root of 4. It would have been quicker, but we still managed to get the same answer. All right. At this time, I'd like you to try your own. Okay, see if you could simplify these 3 square roots, the simplest form.